Okay, so we got a question right here. The coil rotates in a uniform magnetic field at the original angular velocity. The average magnitude V is 3.2. Determine the number of turns in the coil. Magnetic flux density is 0.083 and cross sectional area of the coil is basically 0.048 meter square. Let me write the given stuff that we have been given. There are two ways to do it. Let me write I'm going to do the first way right here, and the second way I'm going to do it in the next video, right? The first way, I'm going to use the simple formulas, which are this formula, right? BA, I'm going to tell you why I'm using this, because and this formula, right? Okay, negative ND by dt, right? Okay, so basically I'm going to use, this is the main formula, right? Because we have been given average magnitude of the V, right? We have been given magnetic flux density and we have been given the cross sectional area, right? And he wants us to find the number of turns, and number of turns can be found through using this formula, right? Other way I can't see, because if we have been given magnetic flux, we could have used this formula, the magnetic flux linkage formula, to basically find the number of turns, but we are not given the magnetic flux, so we are going to use this formula right here to basically find out our answer, right? So let me find basically the magnetic flux first, right? My magnetic flux will basically be 0.083 times 0.0048, and then I get this as 3.984 times 10 raised to power minus 4 WB, right? Web. Okay, so I get this answer as right over here. We have been given magnetic flux density, which was 0.083, that I have written right here, and area, which was 0.0048 meters square, I have written right here. And then once you calculate it, you get your answer, magnetic flux, as basically this. So now I'm going to use this formula, right? I'm going to input the things that have been given. I've been given EMF as basically 3.2. I'm using this formula right here now. Okay, I'm using this formula right here. I use this formula right here, right? So 3.2 is basically equal to number of turns that we have to find. This negative sign, if you ignore it, if you want to write it, you can write it. If you want to ignore it, you can ignore it, because this is the Lenz law, right? And right now we don't need it, because we are not talking about the Lenz law, and it's not, because it's not related to the Lenz law right now. You can make it plus, or you don't, if you don't want to mention it, you have the option of it, but it's just safe to put negative, so you know what you're dealing with. So I put positive for now, right? Okay, so I need to find number of turns. I know that my magnetic flux is basically, which is this d delta magnetic flux. So this is my 3.984 times 10 raised to power minus 4, right? And this basically, d means small change, just remember that. Okay, d means small change, and we can see this is like small change, right? So that's why the formula contains d flux, magnetic flux, right? So remember that d stands for small change, right? So now we have the time, we can be, now we know the main thing, it only turned basically 90 degree out of the 360 degree, right? Because we have taken basically the average of it, basically we took the time. We're gonna take the time because we just turned. For example, you have your basically you have this area right here, right? And you just turned at 90 degrees, because that's much you only need for it to find out the number of turns, right? You don't need to just basically rotate it like 360. You can, but you don't need to right now, not in this situation right now, because you have been given average magnitude, right? So now we're gonna basically write this time as 4 by 4, and you can get the time from the graph, which I got 0.2, right? 0.2 I got, right? I tried to took the average of it. Basically means I took the full wavelength, like the full wave from 0.0 to 0.2. I took that value, right? So once you calculate it, you will get your answer as basically your number of turns will be 4 or 2. This is your number of turns.